Hey, Chem30's Matchak here with your last video lesson for Unit C, and this one is going to be covering concept C8. So we've made our way all the way through Unit C, and we're on the very last relatively short concept for us to cover. I'm just going to quickly right now go over what we're going to be covering in this concept, and then we will jump into just a quick outline of what's going on and proceed from there. Now, I know for this week, I had set up for you guys two concepts. So this is a really short concept on C8 that will sort of wrap up this unit for us. And then there'll be a second video, but I'm going to put that video into Unit D in the Google Classroom that will have you guys working your way through concept D1, which is again a very, very short concept. And then we'll jump into the meat of Unit D next week when we get into concept D2, and probably the hardest concept of the year I find is D3. So we'll get all of that stuff done and sorted out. So this is C8. There'll be another video in the Google Classroom under Unit C or under Unit D for concept D1. So C8 is covering our last little bit. So we're going to talk about polymers, what a polymer is and how we make polymers. So we're going to talk about monomers that can be run through what's called a polymerization reaction and turn them into something called a polymer. And we're going to talk about it from living and non-living perspectives. So we'll look at stuff that would have more of a consumer application to it, so making polymers like plastics, and then we're going to get into talking about some non-living situations where we might get into talking about carbohydrates or proteins, which are also polymers. So that's what we're going to cover for C8. It's going to go by relatively quickly, so make sure you're ready for that. So I've already said this already, but C8 is polymers and polymerization. So we'll talk about how to make long chains for both consumer and biological applications. Condensation and addition reactions will come up again when we start to talk about polymerization, so be aware of that. And then don't forget, as you're following through on your notes, there are some blanks in your notes that you're going to need to fill in using the textbook pages here, which are 445 through 460. So maybe as you're going through the video and following through in the notes, you may want to hit pause at some points and fill in the blanks you might have in the notes that you're taking. I put on 3 relatively short videos here. If you don't get it off the video, and I find most people, it makes sense right away with the explanation I provide. But if for some reason I haven't explained it well enough for whatever reason, and that happens fairly frequently, there are 3 videos here that you guys can tackle. One of them is a good explainer on what polymers are. Then we get into addition and condensation polymerization. And there's lots more out there on YouTube if you need more. For C8, you don't forget to do the fill in the blank notes. That's part of your practice work. Then there's some questions you can do on page 460 of your textbook, 4 questions there. There's a few questions right at the end of worksheet 4, which we did in the previous concept that you may not have answered and you might want to look at answering. Then your practice quiz and your summative quiz. So that takes us through concept C8 and through unit C for us this year. So that's pretty good. So why don't we then just jump right into looking at our last few slides of Unit C. So we are talking about polymers and polymerization. And I'm just going to move that out of the way just in case it interrupts us. So we already talked about what the expectations are. So let's just jump into talking about the what's going on in this unit. So first thing we need to do is just define what a polymer is and what it means to be a polymer. So remember, poly, and we've used this many times in high school so far, poly means many. So we're talking about something that is made up of sticking many things together. And the many things that we're sticking together are monomers, okay? These are the things that we're worried about sticking together. So a polymer is made from sticking together many monomers. How are we sticking them together? Well, we're running them through reactions. We might do an addition reaction. We might do a condensation reaction. We might do something else that we're not going to cover in this unit. So polymerization then is the reaction that links those monomers together to make a polymer. And maybe the suffix mer, think of it sort of as a unit. So a monomer is a 1 unit item. A polymer is a many unit item. Okay. So let's jump to the next slide. So the first kind of polymerization that we're going to be talking about here is something called addition polymerization. And addition polymerization involves rearranging the electrons in double or triple bonds in a monomer to help join it to another monomer. So I'm going to do a little drawing here on the diagram below just to show you what we're doing when it comes to creating a polymer here. Okay, so this is very simple. Addition polymerization is just like an addition reaction. In an addition reaction, remember, we always recognize that there's a double or a triple bond present, and that we're going to go and we're going to break that double or triple bond. So all the way along with these three ethene molecules, which you should be able to recognize, we're going to break the double bond down to a single bond. What that does, and that's what we're illustrating here, is it creates a bonding electron on each carbon that we've just broken the double bond on. So when we've got a bonding electron floating around, then we have the capability to create a covalent bond. And so what ends up happening is these two bonding electrons here get close together and they form that bond right there. These two bonding electrons here get close together and they form that bond. Okay, and what we're starting to do is piece together a long chain, really long chain hydrocarbon. In this case, we're taking ethene molecules and turning it into turning it into a polymer we would call polyethene. Poly meaning many, ethene meaning many of these ethene molecules stuck together. What you'll notice over here is that there's a free electron over there, a bonding electron there, and a bonding electron there. Those two bonding electrons are now free to bond to more ethene molecules on either side. And so we could introduce more and more and more of these molecules to the reaction container and start to add on more and more molecules to make a super long chain of polyethene. Okay, so these monomers sometimes can be turned into a dimer or a trimer, right? 2 or 3, but often this is happening so quickly that we're making hundreds of thousands of them at a time. So it's happening much more quickly than we could possibly imagine. So here are some other examples of compounds that are created through what we would call, I'm going to shrink myself down here. There we go. Created through addition polymerization. So here is something called propene. Okay, so you can see 1, 2, 3 carbons. They've broken it up just a little bit, mainly because it makes it easier for us to show how these are going to be added together later on. So we would again go through the process of breaking double bond, breaking double bond, breaking double bond, right? Freeing up bonding electrons and starting to stick together this structure we call polypropene now, which you may have heard of as polypropylene before. What I want to point out over on the far right-hand side, which is a little different than what we saw on the last one, is that we have basically a representation of a generic version of this polymer, right? And what it's basically showing us is the monomer that was used to make the polymer. And so what we've put are brackets around the polymer, or the monomer, pardon me, and then this is an N down here, as in N number of monomers stuck together. So here's the monomer that started it. Now notice in this addition one, they've already gone through the process of breaking that double bond over here, leaving us with that free bond on either side. Okay, so this is our propene monomer stuck together N number of times, making our polypropylene or polypropene polymer. Another example of this would be polyvinyl chloride, which is created by taking chloroethene. So you can see your chlorine molecule down here, and chlorine atom down here, and we would just go through and break these double bonds, freeing up a bonding electron on each of the carbons, allowing them to be stuck together. And here is our monomer unit stuck together N times. So this is our CC with our chlorine on it, making our polyvinyl chloride, or for us it would be polychloroethene if we wanted to use technical IUPAC terminology. So I hope that kind of makes sense. Some other examples here. Again, notice the the what I'm going to call the polymer notation for this. So this one with the really unusual squiggling that went on over there, I'll kind of take that out. This one is a styrene molecule. So you'll notice that we've got an ethene, but we've got a benzene ring stuck on it. I'm going to break the double bond all the way along here, stick them all together to make polystyrene. Okay, and then down here we've got tetrafluoroethene to start with. So 1, 2, 3, 4 fluorine molecules, double bond, so it makes it an ethene. So it's a tetrafluoroethene. But then now we've gone and created something called polytetrafluoroethene, which is another term for it, a more consumer-related term, which is Teflon. Okay, so this structure over here, being able to create the notation for a polymer, is something that I will test you on at some point in the future. And then being able to recognize what the monomer is in a long chain of something is also important for you guys to recognize as we move to the future. So the other kind of polymerization that we're going to talk about in this lesson is condensation polymerization. So this is just like the condensation reactions we talked about in the last lesson, the condensation reactions that created the esters that we were looking at. And basically this is used in the production of polymers as well. Often we're going to find from a biological perspective. So we're going to be creating polymers in cells using condensation polymerization. And that's what my examples are going to show. And what's going to happen in a condensation polymerization, just like any other condensation reaction, is that we're going to end up with a small molecule that's going to be condensed out. Okay, and then in this case, what's going to be a little bit different is we're going to now start to stick these units together. So in an ester, we kind of created a polymer, but not really, because we took an alcohol and we took a carboxylic acid and we pulled a piece off of one and a piece off of the other, removed that to make water, and then we stuck those two together. If we went and continued adding things on, we would have a polymerization reaction, but that's where we stopped with esters after that first reaction. So what I'm showing here is what's going on to create proteins as an example. So these are two, if you've taken biology with me, you hopefully would recognize that these two things are amino acids. Okay, and an amine, and from some of the videos I may have shown you or you may have watched earlier, this is an amine group stuck onto this carbon chain, whatever it is. In this case, it's an amino acid. And what's happening in this natural condensation polymerization is we're breaking off an oxygen, we're breaking off two hydrogens to remove that small molecule, and now we've created a bond between one amino acid and the other amino acid. That bond is called a peptide bond, and now we've started the process of manufacturing proteins. Those of you that are in Bio 30 right now and are taking Bio 30 or will take Bio 30 in the future, this is the process that is taking place in ribosomes, as ribosomes are reading an RNA molecule and assembling together amino acids in the right order based on what they're reading on the RNA molecule in order to create a protein. And in the process of that, they're creating these peptide bonds through condensation polymerization. And when they are done doing this, we have a polymer that is called a protein. Another kind of polymerization that we can talk about is the creation of starches or polysaccharides. Again, thinking back to Bio 20, we talked about that stuff. And we know that when we stick two C6H12O6s together, so a glucose and in this case a fructose, we can do a condensation polymerization there. And we actually talked about this. If you remember, condensation synthesis is what we called it in Bio 20. So that's what we're seeing going on here. And I may have even said in Bio 20, hey, those of you that are going to take Chem 30, this is going to come up. We'll show you this. Well, there it is. So here is your water molecule being removed. So an H from the fructose and an OH from the glucose. And then that goes off by itself. There's our condensation. We're creating water as a result of this. And now we've created, there's the O from the fructose that has a bond it can attach to the carbon over here on the glucose. Please don't panic at this point. We are not going to expect you, and I am not going to expect you to be able to draw the glucose or fructose molecules from your memory or anything like that. Instead, we want you to be able to interpret something like this. So if we gave you just this picture and said, hey, what's going on? You should be able to tell me, yeah, well, I think I see what's going on is that we've taken a water molecule out, so this looks like a condensation. Hey, and we're making reference to starches or polysaccharides. I wonder if this is part of a condensation polymerization, right? So we're taking steps, baby steps here, but I don't want you guys to think that I have to recreate this from memory. No, you have to interpret something given a bit of context, okay? So that really is my lesson. That's it. That's done. I'm finished. Okay. Just a couple of things to remind you of, and I'm just going to quickly tab back to where I was before. So just remember, please, that we are working our way through C8 here, but you still have D1 to do this week as well. It's going to be as short, if not shorter, than my explanation right here. Don't forget to go in and do your fill in the blank notes. You may have, if you've been following along, you may have skipped over some of the stuff. Don't forget to go back and fill those in because they may turn up at some point along the way. There's some practice questions on page 460. You can finish off worksheet number 4 if you haven't done that already. And when you're done and comfortable with everything, move on to the practice quiz. Wait for feedback from me, please, before you jump into the summative quiz. That's it for now. Thanks for watching. Stay healthy, and we'll talk really, really, really soon when we get into concept D1.